All right, welcome back. Seventh graders, we are on lesson 10.6 today, dividing monomials. And the nice thing is we have one lesson to go, and then we are done with chapter 10. And I know so many of you are getting ready to be done with this, but I'm not. I think it's kind of fun. We got our word monomials back, which we like, and now we are dividing. Quickly think back to yesterday. Yesterday's lesson was on 10.5, and it was all about multiplying monomials. When we multiplied monomials, we knew that we had to multiply, we added our exponents together. And our exponents were used to show repeated multiplication. So we really just had a to the fifth power. Or, our a times a times a times a times a. I could write it out all like this, which ends up with 5a's, or a to the fifth. So since our multiplication, we use our exponents to show repeated multiplication, and we used addition, repeated addition is multiplication, what kind of tool, operation do you think we're going to use to show the division of our monomials, the division of our exponents? What do you think we're going to do? Instead of adding, I bet you could think of a nice little inverse of addition as subtraction. So we're going to jump into subtraction today when dealing with division of monomials. So what we know is a to the fifth over a to the second. We know this means the same as the base times itself 5 times. So we have 4 times 4 times 4 times 4 times 4, 5 times over 4 times itself twice. They're saying that this is 4 to the third. What we notice is, just kind of like we did that example in 10.5, about how numbers cancel each other out. When they do that, 4 over 4, we do know is the same as 1. So those are the same as 1, and when we multiply by 1, nothing changes. So all we're left with is 4 multiplied by itself 3 times, or 4 to the third. Okay, so let's think about what we notice here about some rules for dividing monomials. So unlike the product of powers, remember product was multiplication, we're looking at the quotient of powers. We know quotient is the answer to a division problem. And when we multiplied, we added our powers. So today, looking at our words, they're telling us that we are going to subtract our exponents when we are trying to divide powers with the same base. Kind of makes sense. Addition and multiplication are kind of a positive thing. Dividing and subtracting are a negative thing. So they make sense that we're going to pair those things up. So some examples here. It says 3 to the 7th over 3 to the 3rd. So we follow our rule of subtracting our exponents and take 7 minus 3 for 3 to the 4th. Again, I can check this by, writing them out. So I could write 3 times 3 times 3 7 times, because what that exponent tells me that I'm multiplying 3 by itself 7 times, and that is over 3 multiplied by itself 3 times. So I can do that canceling and know if I get rid of these, I'm left with 4 3's multiplied by themselves. So that does help me check my answer and know that I am kind of on the right track here. Okay? So, looking down here, let's give a couple of these a try. Maybe you want to pause and try them on your own. Maybe you want to see me do them and then give some others in your book a shot first. Whatever works for you, go ahead and give it a try. That's the beauty of these videos. You can stop, pause, rewind. Don't fast forward, though. You want to make sure you see everything. So, here I know my rule is when dividing powers, when finding the quotient of powers, I'm going to just subtract my exponents. When I do that, 8 minus 2, I know is 6. Okay? So that is me simplifying that. If they wanted me to solve, I would just multiply 4 times itself 6 times for another answer. So again here, I'm going to say, okay, the same base is x, and it's x to the 10th over x to the 3rd. So I subtract my exponents for a total value of x to the 7th power. And I'm done there. One term. It's nice and easy. Over here next, kind of like yesterday, we took our coefficients away and we divided them on their own. So this one's going to look like I'm going to take my coefficient of 12 and 2. And I'm going to divide those over here. And it's like I'm multiplying those by my w to the fifth and my w, which is really just to the first power. So what this looks like is I know 12 divided by 2 is 6. I also know that this is supposed to be a subtraction of powers of the exponents. So I'm doing w to the fifth minus 1, which results in 6 times w to the fourth power. Like I said, this is really fun. It's really just finding the things that are alike, putting them together. Either yesterday was adding them together. Now we're kind of just subtracting some away from another. Something else that's going to come up today is that we need to remember our negative exponents. We do need to remember that when we have a negative exponent, we flip it around to its multiplicative inverse or reciprocal. So this negative 2 would then become a positive 2 in the denominator. So let's see some examples with that as well. We also do need to remember our rules that when we are subtracting a negative, that's really the same as if I were to do my chop chop. It's really just like adding. So we need to be careful with those things as well. So here I am, some examples. They want us to express with positive exponents. So meaning, if we end up with a negative, they want us to do that multiplicative inverse and flip those around. So here I have 6 to the ninth over 6 to the negative third. I see that it's a division of monomials, so I know that I'm going to be subtracting my exponents. So I have 6 to the ninth minus a negative third. Like I just said above, we need to be careful about those subtracting a negative, because taking a negative away is a good thing. That's a positive. So it's like I'm adding a positive, and I end up with 6 to the 12th power. So hopefully that's a little bit helpful for you. Now I see at the top of 11 to the negative 8th and 11 to the positive second power. So I say, oh, this is division. I'm going to subtract my exponents, a negative 8 minus 2. Again, I'm going to use my chopping and my ninja skills here to add the opposite. And I see that that is 11 to the negative 10th. I'm not going to leave my answer like that because the directions do tell me to express it with a positive exponent. So I need to go back and remember my rule, okay, about the multiplicative inverse of a negative exponent, and write this is the same as 1 over 11 to the positive 10th power. Okay? Maybe take a minute, pause, and try the next one on your own, and then turn me back on here and see if you can do it correctly, which I'm sure you can. So coming back here, I'm going to divide again, so I know I subtract my exponents. So I have b to the negative 4th minus a negative 7. Adding the opposite, this is really the same as b to the positive 3rd power. Make sure you're being very careful with your integer adding there. The next one again has some coefficients, which is great. I love combining things that are alike, so I'm really going to take these away from those. And it's really like 6 divided by 3 times h to the 5th over h to the negative 5th. So here I am. I know 6 divided by 3 is 2. Make sure you don't subtract those. You are actually dividing your coefficients. So don't subtract those and get 3. Make sure you know you're dividing. So here then I have h to the 5th minus a negative 5th. Very careful. A lot of people might have just subtracted and got 0, which would not be the correct answer. So I'm going to add my opposite. And I have 2 to the 8 times h to the 10th power. So again, make sure, go back and review, rewind, do whatever you need to do to make sure you're coming prepared, as knowledgeable as you can tomorrow, and definitely with some questions. I'd love to hear some questions tomorrow if you have them. But make sure these rules, dividing is like subtracting when you're doing monomial exponents. So have a great rest of the day, and we will see you later on.